Bismillahirrahmanirrahim. Assalamu alaikum everybody. Today we are going to talk about session 9 uh, of the course TM351, and in this session we talk about the distributed transaction, which is part number 17. I will focus on the important points, starting with the transaction, and we are familiar with the meaning of transaction since we explained that before. Once the data to be updated lives on several servers or across multiple data centers, transaction management gets much more complicated, as it must handle the possibility of failure in one or more of the participating servers at any time, while still preserving the integrity of the transaction overall. And we mentioned about that also when we talk about database management system before, and even the scaling out in the previous sessions. So since or if we have multiple servers, then the possibility of failure will be high. Uh, we consider distributed system, which may combine replication and sharding. This is the important of our session today. What is a distributed system that we may use, which have both replication and sharding that we have discussed before. Term nodes could be given in Mongo database to any of the following. Could be a member of replica set, a shard server, both of them, or collection of servers, or even the whole data center can also known as node. Two main issues emerging when we consider how distributed database differ from a single site database. No, remember that centralized database, everything in one computer, okay, or distributed database if we have different computers and the database distributed across these things. So what is the difference? First, we say that parts of the database may fail while other parts remain potentially available. Because we have different nodes or different servers, one of them could be fail and the others still work. The second thing, even when all of them are works, we still find that some of them different in speed comparing to others, some of them faster than others. And some of them take time to propagate data to other servers from other nodes. So this also speed make difference between the distributed system and the centralized database, or if the database only in one exists in one computer. Asset properties, we also, I think you remember this, as we explained this in the first meetings of the course. Asset properties, okay, you remember durability and consistency, integrity, and atomic or atomicity. So each node holds the same information as all the others. Each node can answer queries posted by their clients, and each node can process database updates, ensuring that all other servers in the distributed system also accept the same updates. So if we have many servers and our data is exists on these servers, so any node can answer you or can accept your query. The major problem with distributed databases is that parts of the database may fail while other parts remain operational. The failure could be with the nodes in the database or the network connection between them. Okay, in this case, we don't guarantee the atomicity. if one node is failure or the network is failure, or we have network partition. In this session, we are focusing on network connection or network partitions and not the node failure. You can see here, this is, okay, it's clear here. Um, this is network partitions. As you can see, the two nodes on the right now are separated from the three nodes on the left. There is no more connection because of this network cut or network partition that happened in this distributed system. So this is a distributed system with 5 nodes or 5 servers. Okay, we have something else called cab properties. Uh, these three properties are the consistency across the nodes, the availability of the database to users, and the tolerance of network partitions. So it is a system which using these three properties. This system or this theorem uh, at best can satisfy only two of the three properties that we mentioned, the consistency, availability, or partition tolerance. Conflicting definitions, partitions and availability. For partition, okay, we means communication lost. For availability, it means that the distributed database or any non-failing node in the distributed database will serve all requests. So they are opposite to each other. Consistency. Cap consistency means atomic consistency, which means that each update should appear to be instant. Any update we made on any server or any node should be propagated instantly to all other nodes. So we keep the consistency in this system. Acids atomic and durable are not relevant to the cap theorem. Why? Because this theorem or the cap theorem talking about network partition, and atomicity and durable are not related to network partition, but to node partitions that are guarantee the preserving of rolling back transactions or committing the transaction. You know, remember last time we say if we have problem during the execution of the transaction and the transaction is stopped in the middle, then we should go for rolling back to uh, guarantee the atomicity of the transaction. So since we are talking about network partition and not node partitions, then we are caring about cap theorem and not atomic or durable properties. Okay, you see, this is system. It's clear that it is a perfect system. We don't have any partition here. In all nodes of the distributed system, the data is in the same state. We also mentioned that before when we discussed relational database. What do we mean same state? Means in all servers we have the same data. Any request to any server of in the distributed system is able to to solve your problem or to accept your request and give you the result for that. This is partition in the system. So this node on the right has no more connection to the four nodes on the left. So actually we have a problem here. Uh, Look, this guy is able to access to this server and send his or her request because the node is available. The problem is with the network partition. It is the network partition. And those are able to send their request to also these nodes. But the problem that any update in this node cannot be propagated to other side, or any update made on this node by this client, for example, cannot also be updated to this node. It means that the system is not consistent. The data on the on this side are different from the data on this side, and this is a problem that we may face. So for the entire system to be available, all nodes must respond to all requests, including update request. If the system, if reject the request, the distributed system overall is not CAB available. Yeah, I send my request to a specific server or node, and they're rejected. It means that the system is not available. If one node is not available, then the whole system is not CAB available. If it does accept this request, then as I show you in the figure just now, um, uh, the system will become not consistent because the data exist on the on the right side are different from that exist on the left side of the partition, right side, left side of the partition. So in this case, we may need to sacrifice one of the properties for the advantage of the other one. So we may sacrifice consistency and accept partial availability. When a Mongo database replica set is partitioned, the majority subset of the replica servers will continue to accept all requests, like the four nodes on the left side in the figure that I show you before. And it is better in this case to accept only retrieval and not updates. Okay, so because for retrieval it is very simple, very easy to overcome this problem after or propagate checking the state of the servers, after we resolve the network partition. But if we make updates, then we will have a big problem, and we need to manage the things, which is really difficult. Another way of handling partition, the first way is to sacrifice one for the advantage of the other. The other way is compensation. All nodes continue to accept updates during partition, with any ensuring conflicts will be dealt with after the partition is resolved. For example, if two people are found to have booked the same hotel room during a network partition, like in the figure before, the one on the right and another one on the left of the partition. They have no connection between each other, but the nodes are available, so you can send your request, and these nodes accept both requests, okay, on the right and on the left of the partition. The system overall can resolve the conflict by performing some compensation actions, like, for example, canceling a booking, okay, maybe perhaps offering financial compensation, or maybe changing one of the booking to an alternative room. So if both, for example, on the during the partitions, both booked the room, okay, and it was the same room by chance, then they come to this hotel to take their room. Um Maybe the hotel give one of them give the room, and the other one give him her another room, or maybe um, give some kind of financial compensation for those people. Okay. Uh, Also, we need to remember that ACID transactions cannot take place in the event of a network partition or failure, because it will not guarantee the atomicity and the durability of the data. Base system. This base system's basically available. It sacrifices cap consistency for availability. We need the nodes to be available, and we sacrifice consistency that we may resolve after the network partition resolve. Data visible to some clients may be temporarily out of date. In this case, out of date means here is it means not consistent anymore. Yes, they are available, but not consistent. Why? Because the data is different. Okay, in the both sides of the partition. Repeated queries may thus return different values. Yeah, if I have a query and the same query, and we send it to node X on the left of the partition and node Y on the right of the partition, they will receive different results, even it is the same query. But changes made in one part of the distributed system will eventually be propagated to all parts of the system, and this is what we call eventual consistency. So this eventual consistency means automating the recovery behavior after partitions, and perhaps restricting the types of changes that can be made to the data to allow this recovery to take place automatically. For NoSQL databases, such as document databases, base system is, our base approach is very suitable and very good, because oriented databases like document databases make transactions easier. Okay, distributed transactions in relational databases. In a normalized relational database, this will often require coordinated changes to several rows of several tables, because sometimes we need to get data from different tables, from different rows in different tables. So we need some kind of coordination and management system to do so. Part of a transaction is acquiring looks on all the data to be changed by the updates. So if the database is distributed, updates can be impossible to apply during data partitions, as the database management system may not be able to see all the data that needs to change. We may have different sites or nodes. We have partition